seems like a lot, but everything keeps adding up. All right, so writing vectors in component form, basically it's saying that the vector initial point is not at the origin. Okay, so we have to kind of make it. So to do that, you're going to do x2 or x sub 2 minus x sub 1 and y sub 2 minus y sub 1. Right? So for example, to find a, b in component form, we would do 6 minus 3 and 3 minus 5. Now the question is, why did I pick b to be the first point? Well, that's the terminal point. So since that's a terminal point, you have to go first. You're finding the difference between the terminal and the initial point. So the last point has to go first. So we get 3, negative 2. My handwriting looks real bad today. So on number 11, and I'm just writing these lines to break up my work. That's all I'm doing. We're going to find the component form first. And what I really want you to be careful of is not doing the y values first, because that's typically what we have been doing. With magnitude, we do the y values first. With the directional angle, we do the y value on top. So make sure you do this in the order of x and y. So it's 4 minus 2. And you're going to do 1 minus negative 9, which is adding. Oops, and I wrote the answer, which is 9. Okay, so that gets you 2 and 10. So component form is 2 and 10. Now we're going to find the magnitude, and that's pretty simple. You're just going to take these two, square them, and add them. So you get 2 squared plus 10 squared. 2 squared is 4. 10 squared is 100, so it's 104. So we're going to go ahead and simplify that in radical form because we can. If you take 104 divided by 2, that's 57. If you divide that by 2, it's 26. And you divide that by 2, it's 13. The only group of 2 you can make is the first two. The 2 and 13 can't be put inside or outside. There's no group, so it's 2 square root of 26. All right, and then the last but not least for this problem is the directional angle. So tangent of theta, it's y over x, or b over a. So we have 10 over 2, which is obviously 5. I'm going to go ahead and just write it as the inverse tangent of 5. So inverse tangent of 5 with 4 decimal places is 78.6901. So 78.6901 degrees. All right. Now, 11 gives you the coordinate points, 12 doesn't. So on 12, you definitely have to do that first. So this is negative 1. It goes up 4. So we have negative 1, 4. And this one goes over 1, 2, 3, 4, and up 1. So the first thing I want to do is find the component form. Remember, x values first. Terminal point is here, so we have to do 4 minus negative 1. So 4 plus 1. These are like arrows. My thing just looks really bad. And then 1 minus 4. So that gets you 5, negative 3. All right, the next thing you're going to do is the magnitude. I'm just going to split up the work over here. Okay. So the magnitude is going to be these squared and add together. So that gets you 5 squared and negative 3 squared, which is 25 and 9. And 25 and 9 is 36, just to check. Oh my god, see, this is why I checked, 34. And then we're going to see if we can simplify it. So 34 divisible by 2 gets you 17. 17's prime. So our answer is the square root of 34. And I'm going to put a U here for units because I forgot to do that. Okay. And then last but not least is the directional angle. So we're going to do y over b, so negative 3 over 5. I said negative y over b. Negative or y over x or b over a. Sorry, I'm trying to rush through this. I actually already made a mistake on this video once, so I'm trying to go quick, which is the bad idea. Do inverse tangent of that negative 3/5, which gets you negative 30 degrees, 0.93, well, nope, 9638. So, and that makes sense for it to be negative, okay. You can write it that way. There's another way you can write it instead of being an angle, negative angle, and you take 360 minus that. So we take 360 minus that answer. Or I guess it's, I put addition if I do it here because it's subtracting. That gets you 329.0362. So you can't have the negative. I'm going to say you're not going to want that on Khan Academy. So let's just try to get the positive answer. So you're just taking 360 minus this. Now if you put it in your calculator, it's 360 minus negative 30. You're going to be adding. So you actually just do 360 minus this or 360 plus negative 30. Okay, so just keep in mind how you would do that. Okay, one more thing with equivalent vectors. Okay, so it says vectors are equivalent if and only if they have the same component form. So use component form to figure out their equivalent. So this is our next little piece of information that we could use to find equivalent. So I'm going to highlight this. Okay, so now it's obviously above, but I'm just highlighting it there. Okay, so 13, last problem. Okay, you have AB and you have CD. CD. We don't have those anymore. We do. It's very rare. Anyway, moving on. Not funny. All right, so AB in component form is going to be -7 minus -3, which is adding. The question is why again am I doing -7 minus -3? Well, B is the last letter, which means it's the terminal point, so I have to do that first, and then subtract from A. And they're going to do -2 minus 6, which is adding. So that gets us -4, 4. Okay. And did I do something wrong? No. Okay. And then CD. See, I still want to make a lame joke and I can't. It's not funny. You're going to do -1 minus 3. And you're going to do -9 minus 1. -1, so it's adding. And that makes it -4 and -8. Okay. If these were the same, say if this was -8, then they would be equivalent. But because the last term, the B, is not the same, they are not equivalent. All right, that's it for the notes. If you have any questions, get a hold of me. Get a hold of me through Remind or Google Classroom or through email. If you're sending me daily practices, try to put your name and the assignment on it. It makes it a lot easier to kind of sort through and grade because I have about 80 assignments in my inbox right now that I have to grade. So just try to make it a little bit easier for me if you could. As always, stay safe, stay healthy. All right, see ya.